Today, the global construction industry spends billions of dollars every single year on mechanical systems. We install industrial-scale air conditioning, complex pumps, and heavy-duty ventilation just to keep our buildings habitable in extreme climates. But long before electricity or computer modeling, architects in India were solving these exact same climate problems. They were designing for thermal comfort and water management over 1,000 years ago. India presents one of the most diverse geographical challenges on Earth. A builder might have to contend with the blistering heat of the Thar Desert, or, as we see here, the torrential downpours of the southern monsoon seasons. Because the climate swung between such extremes, builders couldn't rely on a single universal formula. They had to observe the local environment and adapt their designs to survive it. This constant pressure to adapt meant that every design choice had to account for the local geography. It led to a tradition where a building's success was measured by how well it belonged to its environment. This courtyard house is a self-contained environmental system. The layout uses the central opening to actively manage airflow. During daylight, thick walls act as thermal mass, absorbing solar energy. Meanwhile, deep arched walkways stay shaded, keeping interior rooms cool. At night, the courtyard acts as an exhaust shaft. Accumulated daytime heat vents directly upward. This vertical release creates a vacuum effect. Hot air escaping pulls heavy, cool air down into the courtyard, circulating it through the living spaces. This architecture turns the courtyard into a passive thermal engine. It requires zero electricity because it is powered entirely by the physics of the climate. That same ingenuity was applied to a civic scale to handle water scarcity. This is Rani Ki Vav in Gujarat, a stepwell that descends 27 meters into the earth to reach the water table. In regions where water levels fluctuated drastically between seasons, builders engineered a sequence of pillared steps. This allowed the community to securely access the water, no matter how far the level dropped during the dry months. Descending that far below the surface creates a distinct microenvironment. The earth acts as an insulator, keeping the air at the bottom of the stepwell significantly cooler than the blistering temperatures at the surface. This underground climate transformed the site's purpose. These habitable, shaded galleries hosted civic gatherings and religious rituals, turning essential water infrastructure into a cultural center. By going underground, builders took a basic requirement for survival and elevated it into high-functioning architecture. We see this process reach its peak in the monumental temple complexes, which represent centuries of architectural refinement. The Brihadisvara Temple, completed in 1010 CE, is a sophisticated synthesis of structural engineering and urban life. Builders arrived at this scale through continuous experimentation. At earlier sites, like Aihole, they tested different forms, including flat-roofed and apsidal structures, to perfect stone stability. Over time, this hard-won knowledge was formalized into written treatises. Architects recorded their methods in comprehensive texts, such as the Mayamatam. These texts outlined strict modular systems and complex geometric rules centuries before modern design software. They dictated exact site orientations to maximize airflow and provided guidelines on using local materials. These ancient records prove that Indian architecture was a highly advanced, codified system of environmental and spatial knowledge. Being centuries ahead doesn't mean these builders had secret technology. Their genius lay in an absolute understanding of their local geography. Today, architects use supercomputers to simulate the exact same passive cooling and water harvesting systems that ancient builders perfected through generations of observation. It suggests that architecture doesn't become intelligent simply by adding advanced technology. True intelligence means understanding the environment so well that the building belongs to it.